Hello! Welcome back to our subject, Techno. Again, I'm your teacher, Shalome W. Pareja for this subject. For this week's lesson, let's talk about light and pressure sensors. Light sensors detect the amount of light and vary its electrical properties based on the amount of illumination. One type of light sensor is a photoresistor or a photocell. Photoresistors or photocells are light-sensitive devices that detect the presence and absence of light or measure light intensity. The photocell changes its resistance depending on the amount of light it receives. If there is darkness or absence of light, the resistance is very high and decreases with the increase of light intensity. So again, if there is darkness or absence of light, the resistance is very high and decreases with the increase of light intensity. So these are the picture of photocell and the schematic diagram of photocell or photoresistor. Photoresistors are inexpensive and can be found in a lot of consumer items. Street lights and solar street lamps use photoresistors to detect the presence of light, turning on the lamps whenever it is necessary. Camera light meters and night lamp also use photoresistors. Due to its inferior sensitivity compared to photodiodes and phototransistors, phototransistors are not used for light intensity measuring devices. On our upcoming activities, you will be designing an automatic street lamp in one of the activities for our upcoming lessons. Now let's talk about pressure sensors. Pressure sensors measure pressure in fluids or liquids and gases. Pressure is defined as force per unit area and is present in all liquids or fluids, Photoresistors are inexpensive and can be found in a lot of consumer items. Pressure is defined as force per unit area present in all fluids. It is present in the atmosphere due to the air weight and in bodies of water. Pressure sensors come in many types. It can be mechanical, strain gauge, inductive, piezoelectric, and piezoresistive in nature. These types of pressure sensors generally use a force collector such as diaphragm, piston, and others to measure strain due to applied force over an area. Here is we all know that here is a figure of barometric pressure sensor which measures atmospheric pressure. So again, this is the figure of barometric pressure sensor and its equivalent or in schematic diagram. So this is barometric pressure sensor. It measures the atmospheric pressure. So as mentioned, pressure sensor just measure the magnitude of pressure, so it depends on the need for pressure measurement. Some typical applications are flow measurement, leak detection, weather instrumentation, vehicle engines, and others. One popular application for pressure sensor is altitude measurement. Pressure varies with the height or depth. For example, once you go on a higher in the atmosphere, pressure is reduced as air becomes thinner. If you go deeper in the ocean, pressure increases tremendously due to the weight of the water. With that, the altimeter of an aircraft just measures atmospheric pressure to be able to measure its height or altitude. Additional lesson for this week is about Arduino memory. When designing a sketch, sometimes we will encounter out-of-memory problem. These problems are often involved with inefficient use of the same codes over and over again, whereas most of these codes can be comprised into a single variable or function. The following codes deals with minimizing the required memory of your sketch. But first, let's look on the memory capability of our Arduino board. So here is our Arduino board. Our Arduino main chip 80 Mega 329 has an SRAM flash RAM and EEPROM or EEPROM. Flash RAM holds Arduino's bootloader and the entire compiled sketch. The total size is 32 kilobytes. The bootloader uses 500 bytes, leaving about 32,256 bytes for your compiled sketch. Initial variables is first stored in this memory, and when the program starts running, this stored variable will be copied to the SRAM, taking space in both SRAM and flash. The next type is EEPROM. It is an electrically programmable read-only memory. Again, EEPROM or EEPROM means electrically programmable read-only memory. You can use this to store long-term information. Flash memory and EEPROM or raw memory are non-volatile or programs that stays after the power is turned off, while SRAM is volatile and will be lost when the power is cycled. With that, arrays. Array is a group of variables with a similar type that are accessed with a single variable. Determining the type of variable per line can use up to the limited memories of SRAM. So by using arrow, you're not only saving space but also organizing and tidying your sketch. Syntax for array is as follows. So here is an example in a figure above. You can see the example of an syntax for an array. So we have here initialize pins, array size, name of the variable, and variable type. So in the first line, you can declare an array without initializing the pins that you're going to use. For the second line, you can declare an array without defining a size. The compiler automatically counts the elements and creates an array of the appropriate size. In the third line, you can both initialize and size your array. Finally, you can declare an array of type of characters. You just have to add one more element than in your initialization required. It is also to hold the required null character. So for loop or for statement is a loop statement that cycles back and forth through a block of statements until a given condition becomes false. Arrays are often manipulated inside the for loops. Loop counter is used as index for each array element. You can use it for repetitive operation and operation that runs continuously. In this example, a variable was declared inside the for loop, which is optional. Initialization only runs at the start of your for loop. The condition is tested. If it's true, the statement block and the increment is executed. Then condition is tested again. When the condition becomes false, the loop ends. The next is while loop. The while statement function allows your program to loop continuously and infinitely as long as a given condition inside the parenthesis is true. Tested variable must change throughout the loop or else your loop will run endlessly. In the example, this sketch starts with tested variable j set to 0, while the loop statement tests the condition to determine if the input value is greater than 5. If the given condition is true, codes in the statement block is executed. Once j is equal to 5, condition in while statement becomes false and the loop ends. So the increment and decrement. Increment is adding one of series on a fixed scale variable, while decrement is subtracting one series in a fixed scale variable. Variable must be an integer or long. So here are the syntax. X++, the description is increment x by 1 and return the old value of x. ++ x syntax have the description increment x by 1 and return the new value of x. X minus minus or negative negative or minus minus decrement x by 1 and return the old value of x, while subtract sign or negative negative sign x decrement x by 1 and return the value of x. So this is the increment and decrement fixed scale variables. Now let's proceed answering our objective test and performance test. So if you have any more questions or clarifications, or you want to give some suggestions for our upcoming video lessons, please do not hesitate to email me at my email address, my phone number, my Facebook account, and my MS Teams account. Always remember to stay safe and happy learning, everyone. Again, this is your teacher, Shelame W. Pareha. Thank you very much.